Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on October 30th, 2025, just yesterday. The big result is a three-part framework that pulls generalization know-how from video generation into motion generation, delivering a new dataset, a gated diffusion transformer, and a benchmark. And it hits R precision, top 1 of 0.542 and top 3 of 0.825. The paper is titled, The Quest for Generalizable Motion Generation, Data, Model, and Evaluation. And as we will see, the practical gains for open-ended text-driven motion are quite significant. Alright, Figure 1 summarizes the recipe for broad generalization in text-driven motion. Panel A sketches the ViMoGen pipeline that fuses video priors with motion capture, then generates poses through a gated die-T stack. Panel B presents MBench, a benchmark radar chart that scores motion quality, prompt faithfulness, and generalization. Panel C illustrates ViMoGen-228K, which mixes optical motion capture in the wild video motions and synthetic video data. Well, Figure 2 shows the ViMoGen overview, which combines text and video cues to guide diffusion toward high-quality, semantically rich motions. Panel A illustrates how an offline video generator produces motion tokens, then noisy motion and text tokens are fused through a stack of gating diffusion blocks. Panel B details two branches, text to motion and motion to motion. Only one branch activates at a time, so the model balances fidelity and generalization. So Table 1 compares motion datasets and makes the case that ViMoGen-228K combines scale and diversity without sacrificing quality. The table shows total clips and hours, along with whether motions come from indoor capture or in the wild video, and whether labels are ground truth or pseudo-ground truth, which means algorithmic estimates rather than verified capture. ViMoGen-228K lists separate counts for optical motion capture in the wild video and synthetic video to highlight balanced coverage. Compared with web video sets, it emphasizes higher motion fidelity because more entries rely on true ground truth. Alright, Table 2 reports how the models stack up on MBench, which scores both semantic alignment and physical realism. Generalizability means the model handles unseen prompts, not just narrow test cases. ViMoGen leads on the semantic side, with generalizability at 68%. Motion condition consistency also rises, reaching 53%. ViMoGen Lite stays competitive on generalization and shows strong physical metrics, since lower jitter and less foot sliding indicate more stable, plausible motion. So two takeaways stand out. A unified recipe that marries diverse data with a gated diffusion transformer, plus a lightweight distillation, actually lifts generalization and text alignment, and a clear benchmark sharpens how progress gets measured. The broader implication is practical, open-ended text-driven motion for creative tools and robotics. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.